You aren't here to just memorize another list of disconnected concepts. We're stepping away from all that noise right now. What we're actually doing here is taking a deliberate, structured climb. We are moving all the way from utter confusion to absolute clarity, building an understanding of intelligent systems from the ground up.
There is this quiet, kind of creeping anxiety in modern learning. We tend to just assume that if we don't grasp something immediately, we just don't have the capacity for it. We're not smart enough. But pause for a second. What if the problem is actually not your intelligence at all? What if the real issue is simply the chaotic, completely fragmented order in which the world is trying to explain technology to you? I mean, you're handed these random puzzle pieces, a little Python over here, a little machine learning over there, maybe some generative AI hype, and you're just told to run with it.
Yeah, that is exactly how it feels. I mean, you sit there alone at your desk and you've got, 12 browser tabs open. One is promising you can master AI in 30 days. Another is warning you that if you aren't building autonomous agents right this second, your career is basically over. You look at all this conflicting advice, the noise, the relentless hype, and you just kind of whisper to yourself, I think I missed it. The field is moving way faster than a normal person can learn. Well, that feeling of being completely overwhelmed, it's not proof that you can't learn this. Not at all. True understanding actually starts right there, by acknowledging exactly what we don't know and then carefully structuring it. In fact, we have a guiding principle for this entire explainer. Intelligence begins when confusion becomes visible. When we finally stop pretending we already know all the answers, that is when we can actually start building something real. So the absolute first principle we need to establish is simple: problem before tool. It's wild how often we confuse the two, right? A stakeholder might come up to you and say, hey, we need a dashboard, or we want a machine learning model, or let's build an AI agent. Now, those are technical requests. They sound incredibly modern and fancy, but they aren't the actual problem. The real human problem sounds more like our decisions are delayed, or we're losing revenue, or we are completely blind to our inventory risk. Oh, I see. So the dashboard itself isn't the problem, the agent isn't the problem, the actual problem is that human gap in judgment. So building an AI model isn't even really the goal at all, is it?
Exactly. Spot on. A hammer is not a house, and a model is not a decision. Truly useful data work begins long, long before any modeling happens. It begins when someone in the real world is confused or uncertain, and they desperately need better judgment than they currently have.
Okay, so once we've successfully framed that problem, we have to look at the evidence. And beginners usually just open up a spreadsheet and see endless rows, columns, just a massive mess of numbers. They want to rush straight to the intelligent, flashy part, but we have to slow down. Before you do literally anything else, you must ask yourself, what is this data actually trying to remember about the real world? We really need to dismantle this massive misconception that data is reality itself. It just isn't. Reality is the event. Reality is a customer deciding to buy 3 items on a rainy Thursday afternoon. The data? That is merely the trace left behind. It's just a record, a single row, a timestamp. It tells you that something happened, sure, but it doesn't always tell you why. The very first duty of anyone building a serious system is to deeply respect and understand that evidence base. See, this is usually where the fear really sets in for a lot of people. The math. The heavy formulas. It honestly feels like a giant wall designed specifically to keep people out of the field.
And it's so unfortunate because that is how it's often taught, but that is not what it actually is. We should never view mathematics as just a bunch of isolated formulas to memorize. It is a way of thinking. It's about seeing relationships, tracking patterns, and understanding change with absolute clarity. Mathematics is not a gatekeeper. Think of it more like a flashlight in a really dark room.
And when you flick that flashlight on, what it reveals is that the real world is rarely neat and tidy. Demand wildly varies. Human behavior constantly shifts. Small, limited samples tempt us into severe overconfidence. And that right there is exactly where statistics enter the picture. Not as some abstract academic decoration, but as a tool for honest thinking. Uncertainty is a companion, it's not an enemy. Intelligent people remain uncertain precisely because they are reasoning honestly about incomplete information. Total certainty, that usually just hides weakness. Intelligence begins when confusion becomes visible. We've successfully framed the problem, we've gathered our evidence, and we've learned how to reason honestly about all that uncertainty. So now we are finally ready to step into the realm of automated pattern recognition. We are ready for machine learning. Now, machine learning isn't magic, even though it sometimes looks like it. It's actually a deeply disciplined cycle. We take all that messy real-world data, we extract the meaningful signals from it, and we let the system uncover the hidden patterns. Then, crucially, we validate those patterns to make absolutely sure they hold up in reality, constantly looping back to make it better. The machine is systematically learning from examples, rather than just waiting to be explicitly told what to do. Just look at how error calculation actually works in practice. Say a prediction expects 8 sales to happen, but the reality was only 5. The machine doesn't just throw up its hands and guess randomly next time. It measures that exact mistake, that error of 3, and it adjusts its internal parameters to close the gap. It's honestly just like learning to shoot a basketball. You miss the hoop, you adjust your motion, and you try again. That is what optimization is all about. Okay, that makes perfect sense when we're talking about numbers and predicting expected sales. But what about all the modern AI we hear constantly about? How do we leap from simple numerical predictions into this wild world of processing language, vision, and complex text? That is exactly where we cross the threshold into modern artificial intelligence. We have to ask, what happens when we need to represent vastly richer concepts than just numbers on a spreadsheet? The entire secret lies in something called an embedding. Modern AI takes these incredibly rich concepts, whether it's movies, images, or entire paragraphs of text, and maps them out into a vast geometric space. So, if you like a specific movie, the system simply measures the physical distance to other movies in that mathematical space. The closest ones instantly become your recommendations. Think about that for a second. Meaning literally becomes physical distance. And when we break it down like that, the whole grand mystery of modern AI completely fades away. It isn't some incomprehensible, glowing brain. It is architecture. Just think of it as building blocks. First, you have representation through those embeddings. Then, you add a layer of memory to carry sequences of thought. You build retrieval mechanisms so it can go find external evidence. You incorporate attention so it knows exactly what to focus on at any given moment. And ultimately, you establish human review to ensure it actually remains accountable. Is it incredibly powerful? Yes, absolutely. But it is entirely understandable. All right, so once we stack all these architectural layers together and the model is running perfectly on our laptop, we've succeeded, right? We have a fully working AI agent ready to go.
Well, the notebook works. The agent produces a really neat, clean answer. Everyone in the room nods, and it feels like this huge triumph. But here is the hard truth. The demo is not the system. A demo works exactly once in a perfectly controlled environment. A true production system, on the other hand, has to meet a deeply messy, ever-changing real world.
To move from a fragile, neat little demo to a dependable system, we have to introduce machine learning operations. And this isn't just a boring set of IT steps. It's a vital, continuous feedback loop. It's the practice of meticulously versioning our data so we remember the past, which feeds into training our models with real discipline, which then leads to evaluating them against incredibly hard baselines. We only ever deploy with human review, and after that we monitor constantly. A truly reliable system is held together by this unbroken chain of feedback. Because deployment is not a finish line, it is a doorway. The second that model enters the world changes around it. Customer habits shift, seasons change, people actually start responding to the system itself. We call this phenomenon drift. Active monitoring is how our fundamental responsibility to the system continues long after we hit the launch button. Intelligence begins when confusion becomes visible. We return to this anchor one last time, because as we reach the end of all this technical architecture, we have to radically shift our focus. The ultimate question we should be asking is no longer, what can the machine do? The real question becomes, what can the human builders see? Oh man, I completely understand now. Mastering all those Python libraries or memorizing complex neural network architectures, that's entirely secondary. Becoming a complete builder is really about developing the core judgment to frame the right problem in the first place, the clarity to communicate what you're doing ethically, and the sheer responsibility to keep a system accountable once it's out in the wild.
Precisely. You haven't mastered a field just because you can repeat its vocabulary. You've mastered it when you can walk into a deeply unclear, confusing situation and start asking significantly better questions than you used to.
So we want to leave you with this one final thought. This entire journey from scattered, messy data to an intelligent, agentic system is not magic.
It is a structured, layered practice. It demands immense curiosity, but without surrendering your own judgment. Step out of the fog of hype. Start from what is actually true, and build from there. The question is, what will you build when you finally stop worshiping the machine and start framing the problem?